This video will be about limits in business calculus. In previous math classes, you were given a value of the independent variable, usually noted as x, and then asked to find the particular value of the dependent variable, usually noted as y. But there are times where you can't evaluate the function for the independent variable value, but still want to know where the value of the dependent variable is approaching. As an example, you can walk to the edge of the Grand Canyon, but at some point you have to stop walking. You can't reach a point in space, but you can see what elevation would be if you were able to keep walking. Ouch, if you did it. This can be thought of as the value of the dependent variable approaching as the independent variable is approaching a point. This is known as the limit. There are times when you can evaluate the function as you approach a particular value of the independent variable, but this is still the idea of a limit. Now let's explore the concept of the limit. So example number 1, graphical exploration of limits. Consider the graph of this function. What is the value when x is 2? So the solution to this is when x is 2, notice the closed dot at the point 2, 3. So that means y is 3. What is the function value when x is 4? So when x is 4, the function, the y doesn't have a value. The function is said to be undefined when x equals 4. Now, where is the function value heading when x heads to 2? So notice that even though the function value is undefined at x equals, notice that even though the function value at x equals 2 is 3, the function is not heading towards 3 as x heads to 2. Think of it as you're walking along the graph starting at x equals 0, or at x equals 3. As you walk towards x equals 2, you're going to notice you're heading towards the value of 8. So that says y is heading towards 8. Notice now, where is the function value heading as x is heading to 4? So notice that even though the function value is undefined at x equals 4, the function is heading towards 6 as x heads to 4. Think of it as you're walking along the graph, start at x equals 3, or at x equals 5. And notice as you walk towards x equals 4, you know you are heading towards the value of 6. So y is heading to 6. The function is said to have a limit of 8 as x heads to 2. This is long to write, so mathematicians have come up with a shortcut way to write this. You're welcome to write it the long way or the short way. The short notation is the limit as x goes to 2 of y equals 8. Similarly, the limit as x goes to 4 of y is 6. In general, the limit of a function is called L as x heads towards a value called A would be written as the limit as x goes to A of y equals L. So now let's do a new example. Let's find a numerical exploration for limits. Consider the function f of x is equal to the quantity x squared minus x minus 2 over the quantity x minus 2. What is the domain of this function? So the solution to this is that x cannot equal the number 2, because x minus 2 cannot equal 0. So the domain is from minus infinity to 2, union from 2 to infinity. Now the numerical solution, we're going to fill in the table to see what happens as x heads to 2. So when x is 1, we evaluate this function when x equals 1, we're going to get 2. When x is 1.5, we evaluate that, we get 2.5. When x is 1.9, we evaluate the function, we get 2.9. When x is 1.99, we evaluate the function, we get 2.99. When x is 1.999, we get 2.9999. Coming from the other side, if we let x be 2.5, we get 3.5. When x is 2.1, we get 3.1. When x is 2.01, we get 3.01. When x is 2.001, we get 3.001. And when x is 2.0001, we get 3.0001. So find the limit as f of x. It looks like f of x is tending towards the number 3 as x tends towards 2. So the limit as x goes to 2 of my function f of x equals 3. Now let's do an algebraic solution. We're going to simplify the function using algebra, and then we're going to find the limit. So we need a little bit of space here. So f of x is equal to x squared minus x minus 2 all over x minus 2. Factoring the numerator, you get x minus 2 times x plus 1 all over x minus 2. Simplifying this, you get x plus 1 left. So the limit of f of x as x goes to 2 is equal to the limit as x goes to 2 of x squared minus x minus 2 over x minus 2 equals the limit as x goes to 2 of x minus 2 times x plus 1 over x minus 2 is equal to the limit as x goes to 2 of x plus 1. Well, I can see that I can put 2 in for x, and I get 2 plus 1, which actually gives me 3. Now, let's use the graph to find the limit of f of x as x tends to 2. So the solution of this, looking at the graph, as you travel along the function towards 2, the value of y tends towards 3. So that says that the limit as x goes to 2 of my function f of x is equal to 3. Another concept is the limits from the left and the limits from the right. There are times when you travel along the function from just the left or just the right. Look to see what happens with these limits for the different sides. First, the symbol used for the limit from the right is the limit as x goes to a with a plus sign of f of x. And the limit from the left is the limit as x goes to a with a little minus sign above the a of f of x. So, example number 3. Find the limit from the left and the limit from the right as x goes to 2 and as x goes to 4. So we'll travel on the graph from 0 to 2. The y values tends towards 8. So the limit from the left as x approaches 2 from the left of f of x is 8. While traveling on the graph from 3 towards 2, the y value tends towards 8. So the limit from the right, limit as x goes to 2 from the plus of f of x, also appears to be 8. Notice they are both the same value. This means that the limit as x goes to 2 of f of x is in fact 8. While traveling on the graph from x equals from 3 towards 4, notice the y values are tending towards 6. So the limit from the left, as x approaches 4 from the left, appears to be 6. While traveling on the graph from 5 towards 4, the y values tend towards 4. So therefore the limit as x goes from 4 from the right of f of x appears to be 4. Notice the limit from the left and the limit from the right do not tend towards the same value. This means that the two values do not meet and the limit does not exist. Limits. That means that the limit does not exist. Limit existing means that the limit from the left as x goes to a of f of x equals the limit from the right as x goes to a of f of x equals the limit as x goes to a of f of x equals some number called L. If the limit from the left and the limit from the right do not equal each other, then the limit does not exist.